Okay, in this experiment, just now you were asking a question why we have a 7.9.7 here. But we need to recall one formula, that is F, force, equals to the mass times acceleration. Therefore, in this experiment, the target is assume that we don't know what is acceleration on Earth. Okay, anything who has an unbalanced force, which has an unbalanced force, will has an acceleration. For example, if I threw something, right, I give a force, and it is able to accelerate to somewhere. You know, on Earth, right, all the objects are under a force, which is called gravitational force, right, which is G-force. Therefore, as long as one object got its mass, it's supposedly to have an acceleration. Therefore, in this experiment, we are trying to find the relationship between the force and the mass. Okay, but here we don't have anything called force, but we have something called weight. Okay, what does weight means?
How heavy the object is.
How heavy, that is something very confusing. From now on, right, weight is a force. How heavy is mass? 一个是重力，重量，一个是质量。Okay, weight is 重力, it is a force. The unit for weight is Newton.
重怎么写？
Yeah. Weight. And the other thing, mass. Mass is a measure of quantity, matter's quantity. Quantity. N-T-I-T-Y. Yes, quantity of matter. That means how much matter does one object have means mass.
Mass 就是
Mass, yeah, the unit for it is kg.
重量是吗？
它是质量。质量。我们看质是什么？就是我有多少东西，对不对？量呢，就是有多少，对吧？比如说我身体里有水有多少，有 fat 有多少，有 protein 有多少，对吧？我们说减肥的时候，我们要减掉 fat， 所以我们要 lose fat， 那我们减掉的是 mass。我们身体里的 fat 少了，那么 lose mass. Right? Okay, so this is the most important two quantity, which is the weight and mass. If you can separate out these two, everything will be easier. Okay, so in this experiment, what does it do is it record different object with their mass and weight. Okay, mass we use a balance to measure. Okay, right here, measure by balance. But weight we can use a spring force measurement. Right? Can you recall that we use the spring measurement to measure the friction of an object? If I have a spring measurement, right, I pull this foam, right? So I can measure the force, right? We are measuring the force. Therefore, we are measuring the force, which is the weight if it is on the earth. Okay, so it is a force. And we have the object mass. Therefore, we have two values that we need to find the relationships. Okay, definitely more mass, more weight, right? Accordingly, right? More mass, more weight. With the increasing of the mass, we find it is an increasing of weight. Therefore, we use this equation y equals to mx plus b to find the relationship between x and y. X normally is the independent variable, and y is the dependent. Okay, in this case, this is the mass, and this is the weight. That is like, for example, right, if I gain 1 kg on my body weight, how much gravitational force increase? It is increased by 9.81 Newton. Therefore, I know that 1 kg will equivalent to 9.81 Newton of force. Therefore, we have some number nearer to 9.7. Okay, by mathematics method. So this is the what that the experiment want us to do.
But I don't know M and B.
M and B, yes. This M and B is, the M is slope and M is mass. Okay, that means if this one is 9.81, right? That means 1 kg of X will lead to 9.81 Newton of Y. If you increase, followed by that. I increase 1 kg, you increase 9.81. I increase 10 kg, you increase 98.1.
So the gravity is weight?
Yes, good.
Always? Or only in that?
Gravitational force is equals to weight. It's the same thing. They are the same thing. With different name.
Wait.
So it's gravitational force. Gravitational force is weight. They are same. Weight is a force. Gravitational force is weight. So when they are asking you what is the gravity of it, then you know you're asking the weight. The thing is very confusing in physics is because in normal days, right, people will always ask you, what is your weight? My weight is 50 kg, 90 kg, 60 kg, right? But that is very confusing. Therefore, in the physics world, right, we're supposed to ask you what is the mass of you instead of the weight. If you ask me what is my weight, I won't tell you my weight is 70 kilo. I will tell you my weight is 700 Newton. Okay? Actually, I will ask you, you are asking the weight on Earth or Moon or Mars? Because on Earth, my weight is 700 Newton. On Mars, my weight is 100 Newton. On Moon, my weight is maybe like 120 Newton. It depends. But mass don't change. If you ask me what is my mass, I will say it's 70 kilo no matter where. That means once you fly into the space, you don't have any gravity.
So mass changes.
Mass don't change, but weight will change.
Weight changes due to gravity.
Due to different gravity, yes. That means on Earth, right? On Earth, the gravity, which is the acceleration, acceleration is 9.81. Do you remember what is acceleration's unit?
Gram.
Meters per
second square.
Good. This is acceleration. Okay, that means on Earth, right, if you drop something, the acceleration will be this. But on the moon, right, you drop this thing, it will take longer time to fall into the ground because the acceleration is lower. That is why, right, if you see the video once people landed on the moon, right, they are wearing a very heavy suit, which is around 60 kilo of the suit, but they still can jump very high. The weight plus their body weight and the mass of them is like 300 or 200 kg. If a people is 200 kg, they basically cannot walk on the Earth, but they can jump on the moon because they have a lower gravity. So their weight is lower. Right? If a 200 kg man on Earth, right? 200 kg man. This man on Earth the weight is equal to 2,000 Newton. That means on the two leg you must support 2,000 Newton. But 200 kg men on moon, they are still 200 kg. The kg don't change, the mass don't change. They're still 200, but their weight is 1/6 of the original. It's around 300 Newton, which is just like a 30 kg man on the Earth. So with the same leg muscles, they can jump higher.